again, even though, you know, we had some issues with that last time, but I like it because it pops a little bit better with the color. All right, we're going to talk about linear versus non-linear. When you hear the word linear, what word do you hear embedded in there? When I say linear. You think straight. Why do you think straight, though?
Like, if it's linear, it's going to be like...
Right. What part of you're hearing the word line? So when we've got something linear, we're thinking that it's going to be a straight line. When we've got something that's not linear, this is going to be something that is not a line. So we're thinking about something else. It's got some curvature to it. So kind of like, remember when you were calling it the rainbow graph because it had that shape, right? Those are parabolas. Is that a line? No. All right, so let's talk about things that are a line. So all these things go with things that are linear. So the first thing says that it's raised to the power of 1. So for example, a line could look like this. This could be an equation of a line. Do you see how I have my x here and there's nothing with it? It's just an x by itself. That's a line. You could have a number in front of it, like 3x. That's also a line. But when we're talking about something that is not a line, it would look like this. Have we seen the little numbers that go up high? What do we call those? Exponents or powers. Yep, powers is another good word. So if it's raised to the power of 1, then it's linear. So both of these are 1s. Do you see how there's nothing, there's no little exponent, so we assume that there's a 1 there. This one has a 2, so that's not going to be linear. The other type of line, or not a line I should say, would be if you have something like this. Have you ever seen them before, equations before, where you have a variable in the denominator? Yeah, so that's also one that's not a line. So in order for it to be a line, basically our equation needs to be a line too, right? So we've got everything on the same level and we have no exponents. So both of these things would fit into not linear or not a line. So the graph is a straight line. We already talked about that. What it is, we just gave a couple examples of what it is. They're right here. Again, they're all things where it's just an x and there's no exponent or power. And then what it isn't, that would be kind of what's over here. So what isn't linear? The stuff that's over here. So that would be things with a different exponent or where your x is in the denominator. Another common way that we see lines written, have you heard y equals mx plus b before?
Yes.
Does that sound familiar? Slope-intercept form, yes. So if something can't be written in this form, then it's not a line. So that's kind of a test that you can do. Can I write it in that form? If I can't, then it's not a line. So let's look at a couple examples. Notice that it says justify your answer. What does justify your answer mean? Justify means what? Prove, explain. Like we've got to make sure that we don't just say, is it linear? Okay, yes or no, but also then why? And that'll help you too. You know how we were looking back at notes and we just had like I have yeses and no's. So this will help too when you look back at your notes and you're like, oh, I wrote down why it's linear. All right, look at the first one. Look at where your x is that is off to the side. Do you see how with this one the x was in the bottom when I said it wasn't linear? So this one, number 1, is going to be linear. And then if I had to say y, I would say x is raised to the first power. Can't really leave enough room to write in there. So again, the x can be over here, it just can't be in the bottom of the fraction. So bottom of the fraction is a no-go for something to be linear. If it's off to the side or in the top, that's fine, but the bottom is not something you can have. And then zoom in a little bit, so looking a little harder at it then. Let's look at number 2. What do we think? Linear or not? Look at your x. Look for your variable. Linear? No. So not linear. And then we have to say how we know that. So not linear. So we can say because x is raised to the second power. So instead of being raised to the first, instead of being raised to the first power, it's being raised to the second power. So that's how we know. Take a look at 3. What do we think about 3? Linear or no?
Yes.
I hear a couple of yeses. I agree with yes, it is linear. Why is it linear? Look at your x. What's your exponent?
Which power?
First power, because there's nothing there. So x is raised to the first power. So again, you're always looking for the x. How about number 4? If I look at number 4, it's written a little bit differently, but is x being raised to the first power?
Yes.
Yes. So this one is also linear, even though it looks a little differently, because x is raised to the first power.
Could you say yes because you can write it in y equals mx plus b?
Yeah, that would be fine too. So there are different ways you could say it, and they're still correct. They're just different ways of kind of wording the same thing. So we talked about the fact that in order for it to be linear, it needs to be in the form y equals mx plus b, which we said was slope-intercept form. So Miss Littleton said, what if I wrote it's linear because I could rewrite it in the form y equals mx plus b. That's also a good argument for that. Alright, the next part's a little bit easier because we don't need justification, we just need linear or non. Number 5, is that linear?
Yes.
Yes. Linear. How about 6?
No.
6 is non-linear. That's not a line. How about 7?
No.
Non-linear. And notice it doesn't say justify, it just says tell me what it is. How about 8?
Yes.
Yes.
So number 7 is a little tricky for some of us because it kind of looks like number 5 up above because it goes kind of like from bottom to top. So why is that not a line? Because the arrows are still totally moving. What are you doing? Yep.
And it's got a curve.
It's got a curve to it. So it's not a straight line shape. Curved line. Right. So it needs to be non-linear.
So when we've got some curvature, we're not going to be a straight line. So those are a little bit easier, and again, you don't have to justify, so they went a little bit faster than the other ones too. Alright, so that's topic 1. Do we feel like we could look at either an equation or a graph and decide linear or non? Okay, because that's going to be part of the homework that we get to in just a minute. Okay, let's flip. We've got a couple more, or not a couple more, we've got one more topic with a couple more examples. Alright, x-intercept. An x-intercept is when your graph crosses the x-axis. And the y value is always going to be 0 at that location. So think about an x-intercept. So I could draw one here. So this is my x-axis. And so if I look at where my graph touches, it's right here. And that point would be 1 comma 0. So this would be my x-intercept. That would be where my graph touches the x-axis. It's over 1 up 0. So the location of that point would be 1, 0. So thinking about the other way, if you have a y-intercept, it's where it crosses the y-axis. And what do you think the x value is going to be there? 0. So let's look at a picture of that. So let's say this is my line, and I cross the y-axis this time at 0, 1. So this one would be 0 because you're not over any, but you're up by 1. So we want to find our x and our y intercepts. So I think I'm going to use 2 different colors again. I felt like that worked okay the other day when I was trying to show 2 different things. So I'm going to grab a second color here. I'm going to do my x-intercepts in blue. So here's my x-intercept. And here's the good news. For our x-intercept, first of all, I'm going to abbreviate it. Are we okay with INT for intercept? Okay. Our x-intercept, we only need to write down one number. Where does it touch the x? 12. And that's all you have to write. So your x-intercept is 12. Now, if you want to, you can write 12 comma 0, but you don't have to. Again, the 0 because you're not up or down any. Okay? But you can just write 12. Let's do the y-intercept next. So here's my y-axis right here. I made it green. Where's that one going to touch? Also 12, but be careful. If it's down below, negative 12, there it is. And it's kind of hard to tell, but there are negative signs out front there. It's just, again, it's a little tricky when there's lines and so much more going on. All right, let's look at number 12. Let's go x-intercept first. And again, you can always assume we're counting by ones unless I tell you otherwise. So there's my x-axis. Where does it touch? Negative 1, agreed. So my x-intercept is negative 1. My y-intercept, there's my y-axis. Where does it hit the y-axis? Negative 2. Question.
So for y, it's in the middle.
We're gonna say that it's close enough that it hits it too. We're gonna say that it's close enough.
Alright.
I'm not gonna give you a trick question like that where
I was gonna say,
because I'm looking at number 4 and I don't love number 4, although it's counting by 2, so I think it really is technically okay. Alright, let's we'll get there in a second. Let's go x-intercept first for number 13. X-intercept, where does it touch?
0. I don't know, actually. I don't know.
You were right. Your first instinct was right. You said right at 0, and you're right. It touches right here at 0. Where's your y-intercept?
0.
Also at 0. So your x-intercept and your y-intercept are actually the same spot here. Alright, let's look at 14. Again, I'm not going to give you one quite this tricky on a quiz or test or homework or anything. I think we can handle this one though. So take a look at this line. Here's my x-intercept. There are 2 of them. You see that?
Oh yeah.
I see 2. It touches twice. Now, do you see how these are counting by 2s?
Yeah.
So halfway in between
So
would
it'd be
be
1 and 3.
it would be 1 and 3. But since it's on the negative side,
Oh yeah.
negative 1 and negative 3. So when you have those rainbow-shaped graphs, parabolas, they're going to sometimes touch twice. And again, if it's halfway in between and we're counting by 2s, then that would be at negative 1 and negative 3. Okay, let's look at our y-intercept.
2.
2. Okay. Now, last example I want to show you. What if instead of giving you graphs, what if I gave you a table and some information instead? So if you look at 15, for his birthday, Juan was given a gift card for his weekly online video game subscription. The funds remaining on the card after the week are shown. What are the x-intercepts and the y-intercepts? Okay. So think about your x-intercept. So remember, this is my x column, this is my y column. My x-intercept happens when what is 0? Look back up at your notes. My x-intercept happens when what is 0? Y value is 0. So go back to your table. So at 5 weeks in, that's where my x-intercept is. Let's try the y-intercept now. The y-intercept happens when? When the x is 0. So when is that? 50. That's when you have $50 left. So you look to the other number, and that's going to be your value. So when you have an x-intercept, that's telling you when you reach 0 in terms of the available funds. So you have $0 left. And when you've got your y-intercept, it's talking about time 0. So for those, each one of them is talking about a value of 0. It just flips which one it is. So for the x-intercept, it's when you have $0 left. For the y-intercept, we still had $50, but it was at time 0. Alright, so I'm going to give you some problems to try, and then we will talk